All right, welcome to lesson 7.2, finding real and complex solutions for polynomials. In this lesson, we're going to solve polynomial equations by finding their roots and zeros. And in order to do that, we're going to be factoring polynomials. So we're going to be using our skills of factoring and also synthetic division to help us factor polynomials. Two important facts. First, these real solutions to a polynomial equation, they tell us the zeros of the function. And if you think back to one of our previous lessons, those zeros are the x-intercepts. It's where the graph crosses the x-axis. And that helps us sketch the graph. The other important piece here is that these solutions can be real and or imaginary. And it could be a mixture. You might have all real roots, you might have just imaginary, or you might have some of each. You might have two real solutions and two imaginary solutions. So let's take a look at an example. So here we have a polynomial that is already factored for us, and it is set equal to 0. So just like quadratic equations, we want it set equal to 0. We want to factor the left side, and here we do have it factored, and we can use that zero product property and set each of these factors equal to 0 to find the solution. So I'm going to take the first one here, this x minus 1, set it equal to 0, add 1 to both sides, and I get x equals 1. That's one of my solutions. All right, let's go to the next factor, x plus 5. So x plus 5 equals 0. Subtract 5 from both sides, and I get x equals negative 5. There's another solution. Let me change colors. I think I'll change to red here. Take the next factor, x squared plus 4 equals 0. I'm going to start by subtracting 4 from both sides, and I get x squared equals negative 4. All right, I'm going to take the square root of both sides. That will give me just x on the left side equals, I'm going to have a plus or minus the square root of negative 4. Okay, I'm going to rewrite that right-hand side. I still have the plus or minus, and I'm going to rewrite that as the square root of 4 times the square root of negative 1. So hopefully you realize that this is going to be an imaginary answer. So I have plus or minus the square root of 4 is 2, and the square root of negative 1 is I. So looking at our solutions, we have a solution of 1, negative 5, a positive 2i, and a negative 2i. So we have two real solutions and we have two imaginary solutions. So I'm going to just write those as a set. So one solution is 1, the other one's negative 5, positive 2i, and a negative 2i. Those are our four solutions. Okay, here's our next example. Again, we're going to solve this polynomial. On the left side, it is factored with an x out front and x squared minus 4x plus 8. And if you look at that trinomial, we can't factor it any further. I can't think of any two numbers that multiply to give me 8, but add to give me negative 4. So that's as far as that will factor. It is set equal to 0. So we're going to begin by taking each factor. So we have this x out front, so that gives me x equals 0. So that's one of our solutions. I'm going to take what's in parentheses, x squared minus 4x plus 8 equals 0. And let's think back to how we solved it. This is a quadratic equation, so it equals 0. We can't factor it, so our other option is to use the quadratic formula. So recall, we have A, B, and C. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to pause the video and let you substitute in the correct numbers. There's a quadratic formula with the numbers substituted in. Let's keep simplifying. I get 4 plus or minus the square root. Negative 4 squared is 16 minus 4 times 8, which is 32. So that's 16 minus 32, which I believe is a negative 16. So let me scroll down so I can get some more on the page here. All divided by 2. Let's keep simplifying. 4 plus or minus. Now, the square root of negative 16, I'm going to treat that as the square root of 16 times the square root of negative 1. So that's going to give me a plus or minus 4i, all divided by 2. I can simplify. I'm going to divide each of these terms by 2. So this gets divided by 2, which is 2. This gets divided by 2, which is 2. And that just becomes a 1. So our final answers are 2 plus 2i and 2 minus 2i. So those are the imaginary solutions. So I'm going to zoom back up here so we can list all of our solutions. So all of them, one of them is 0. The other two are 2 plus 2i and 2 minus 2i. So in this example, we had one real solution, and then we had 2 imaginary solutions. Now, one other way we could have solved this quadratic equation right here, rather than using the quadratic formula, you could have completed the square. If you remember completing the square and you like that method, then you could have used it here rather than the quadratic formula. In example 3, rather than asking you to solve the equation, the question says to find all the x-intercepts of the function. Well, by now, hopefully you realize that x-intercepts are zeros. And in order to find zeros, we set the equation equal to 0 and we factor it. In this problem, you're given the function, but you're also given a divisor, x plus 4. So let's factor this one by synthetic division. So I'm going to put negative 4, 2, 13, 17, and negative 12. I'm going to bring down the 2. That gives me 2 times negative 4 is negative 8, which is add, you get 5. Negative 4 times 5 is negative 20. Add, I get negative 3, and negative 4 times negative 3 is a positive 12. And I should get 0 because we said it was a divisor, and so it would be 0. So I get, if I factor this, I'm going to start with x plus 4. That was our original divisor. And the new one is 2x squared plus 5x minus 3. And we're going to set all that equal to 0. All right, 2x squared plus 5x minus 3. That looks like a trinomial that we can probably factor. Now I'm going to do this by guess and check. I know 2x squared means this has to be a 2x and that has to be an x. And to get negative 3, I've got a 3 and a negative 1, or I might have a negative 3 and a positive 1. I'm going to try some different things. I'm going to say, let's say 1 and 3 right here. And I'm going to put the negative here and the plus here. And if I do a quick FOIL here, the inner, that gives me a negative 1x. This gives me a positive 6x. So when I add those together, negative 1 plus 6, it does give me a 5x. And the negative 1 times 3 is negative 3. Now, if you don't want to use guess and check, you can always use the AC method where you're multiplying 2 times negative 3. So that's why it's called AC, because you're multiplying A times C. That gives you negative 6, the two numbers that add to 5. And then you can use the slip and slide method, bottoms up, or grouping. So back to our problem, I'm going to bring down that x plus 4 is all set equal to 0, and let's find our solutions. So here I get x equals negative 4. Here, set that equal to 0, and I get x equals 1/2. And this one will give me, that factor will give me x equals negative 3. So in this example, we factored it by synthetic division, and then factored the trinomial further, found our 3 real solutions. All right, just to summarize, for polynomial equations that are very similar to quadratic, you must make sure the equation is set equal to 0. You want to factor the polynomial, so whether that is using a grouping, that's using difference of squares, using sum or difference of cubes, factoring a trinomial, or using synthetic division, whatever you need to do to get it completely factored, set each factor equal to 0, and then solve each of those. And you're going to list the real and any imaginary roots.